Now, suppose you have a single equation. This x, suppose make it simple. Let's assume this x is just the one single function whose derivative, second order derivative is equal to a certain expression, f. This expression is in terms of t, x, and first order derivative of x. So how can we reduce it to a system of first order? That means I want to get a system that involves only first order derivative. Also, not only first order, I want it to be autonomous first order system. That means I want the right-hand side not depending on t. Okay, so let's first make it make this equation into first order. That means I really want to define the first derivative of x as a new function. So then second derivative of x. So suppose if I call first derivative of x v, then second derivative of x is simply first derivative of v. So that's a way to reduce the order. We just introduce a new function, and then the new function, that means x prime will be our v, right? A new function. So now if x prime is v, then x double prime will be v prime. So now v prime, which is x double prime, will be equal to f t x and x prime. X prime I can use v to represent. So now the system has been reduced to first order. You see, if you write into a system of two equations, it is a system of this x and v, right? So the right-hand side will involve x and v. So the first equation's right-hand side involves v. The second equation, the right-hand side will be this expression of capital F that depend on x, t, and v. However, this is not autonomous. The reason it's not autonomous because this t, you see the t variable is still a variable appearing on the right-hand side. So we want to make it disappear. And so how? So let's just simply define a function. Suppose we call a function u, which is t. So I want to replace the t with a u. Therefore, u derivative okay, so the u derivative will be 1. So my goal is just simply I want to make t disappear. So my u is actually t. I know the u's derivative with respect to t is 1. So with that, this t will be u. So now we have three equations. See, second order has been reduced to first order. So nothing is for free. When second order is reduced to first order, then we get one additional equation. And also when the non-autonomous is made into autonomous, we introduced another equation. That is u derivative is 1. So now this from originally one equation of second order non-autonomous, now we have gotten three equations of first order but autonomous as well. So this uxv we can write uxv first derivative and the vector field depend on only uxv, right? That is the right hand side. So right hand side, see the another vector, which is our vector field, also depend on u, x, and v. So it does not depend on t explicitly and more. So here we have achieved the reduction of order. Also obtain an autonomous system. So let's do one more problem. Assuming I have let's assume I have another equation of higher order. Suppose I have a fourth order. And fourth order equation, suppose x is just a function, not the vector valued function, just a single function. So the fourth order derivative of the function is some expression, for example, can depend on the x or the t and plus x third order derivative minus 2 the first order derivative squared. So I have this equation. Can I reduce it to first order system? So my goal is to reduce this fourth order equation of x, right? Differential equation of x to first order autonomous system. To reduce it into first order, so we see that we better introduce some new functions. For example, if we define third order derivative as a new function, then this fourth order will be first derivative of that function. So our goal is to write, for example, third order derivative. And consider that as a new function, then the fourth order derivative is simply first derivative of that function. So we need to give a name to the third order derivative, for example. So that is actually our strategy to reduce the order of derivatives. So our strategy here, so before we reduce it, let's name. So this X, let's invent a new name for X. It doesn't matter if you change the name of this unknown function, it's still the same equation. So let's let U, right, is the same as X. Then first derivative of X, let's call it U. If the previous one is U1, then let's call it U2. And second derivative of X, then we will call it U3. Third derivative of X will be U4. So this is just to have a consistency in the notation. You see this, if original function, this X is called U1, then first derivative, we name it as U2. Second derivative, we name it as U3. Third derivative of X is named as U4. So it's just for consistency. So let's see, with that, we can discover the U1, U2, U3, U4 are related, right? Because U1's derivative is equal to U2. U2 derivative, that means derivative with respect to t, will be U3. U3 derivative will be U4. You see, we just try to see U3's derivative will be equal to U4. But U4's derivative is what? If you take a U4 derivative, then which is a fourth order derivative, right? So we can have one more equation, which is a U4 derivative, which is the right-hand side. You see, U4's derivative is this, X. X we already renamed. We call it U1 minus T plus X third derivative, see, which is U4, because we see this again, X third derivative, which is U4, right? We want to use U4. Minus twice of first derivative squared, right? We want to use U2 squared. So U2 squared. So this last equation is based on the given fourth order, because U4's derivative, which is X to the fourth derivative, which is given. So this equation is, the last equation in the system is actually based on the original equation. So now we have how many equations? So we reduce fourth order, a single equation, to a system of 4 equations of first order. So here we have 4 equations of first order. However, this is not yet autonomous. Why? Because there is a t. So you see the t variable here. So we want to make sure that t does not appear in the vector field. So let's make t disappear. Just introduce another u. So to be consistent, again, let's introduce a u naught. So our u naught is actually the t. So therefore u naught derivative is 1. So if you want to remind yourself, your u naught is actually the t. So to make t disappear from this right-hand side, so we name it as u naught. Okay, so now let's replace it with u naught. Whose derivative is 1. So therefore, we have one more equation. So now look at the system. Again, it is a system of first order. Also, it is autonomous. So this autonomous, so fourth order non-autonomous has become first order autonomous, but with 5 equations. So if we write the system, we can see in the vector form, which is u naught, u1, u2, u3, u4. The derivative of this vector is equal to a vector field depends on u naught, u1, u2, u3, u4. That is autonomous. So this is another vector 1. So u2, u3, u4, and the last component of the vector field. Okay, so through the 2 examples, you see the techniques, how we can possibly reduce a higher order non-autonomous problem to a system of first order autonomous. So now finally we get a first order autonomous system.